Some questions you have to infer what's missing. A water tank loses 5% of water every hour. What percentage of water will be left in 3 hours? Give your answer to 3 significant figures. We need the same formula, initial times by multiplier to the power of time. Now this one might catch a lot of people out. The question's asking what percentage of water will be left. It's not telling you how many litres of water there are. So whatever is in that water tank at the start is 100% of whatever is in there. So whether it was 1 litre or 30 litres, it's 100% of what was originally there. And we're taking away 5%. So that would be 100% take away 5. So your initial amount is 100 because it wants your answer to be the percent that's left. 100 times by the multiplier, which is 0.95, because remember, we want our number to get smaller, so we don't include the 1 in that one, to the power of 3. Put that in your calculator. 100 times by 0.95 to the power of 3 equals 85.7375. The question asks you to give the answer to 3 significant figures. So look at the first 3 figures, 85.7. Just check whether you need to round that 7 up before you get rid of the rest. And that's 85.7%. We still don't know exactly how many litres, but we know how many percent is left. Sometimes questions are phrased like this, and it does look harder than it really is. The balance of a savings account is B pounds, and it's given by the formula B equals 5,000 times by 1.02 to the power of t, where t is the number of years since the account was open. The first part of this question, what was the balance of the account when it first opened? This is really just checking your understanding of what the formula means. If you remember that that initial amount is what was in there to start with, and that's always in the formula. The initial amount is 5,000, so that's how much was in the account when it opened, £5,000. B, how much is in the account after 7 years? Give your answer to the nearest penny, and this is what we've just been doing. So we're going to calculate this and add on the extra interest. Using the formula, the initial amount is 5,000, the multiplier is 1.02, and the time, this particular question, is asking us what's in there after 7 years, so that will be your power. When you've put all that in your calculator, you'll see that you get 5,743.428338. And remember, this is money, it's asked you to round it to the nearest penny. Check what's in the 1 pence column. Do you need to round it? Yes, you do. So that 42 pence will become 43 pence. There's a third part to this question. What was the rate of interest on this account? Again, this is just checking your understanding of what goes into the formula. In that formula, it's times by 1.02. Remember, the actual rate of interest, you don't include what was already in there. So looking at that 1.02, you're just looking at the 0.2 and working out how many percent that is. And that's 2%. Here's a different kind of way a question could be asked. A tree grows 30% each year. If it was 2 metres when planted, how long will it take to exceed 12 metres? Again, put in the formula, and what we have that will go into the formula. We have the initial amount, which is 2 metres, and we have the multiplier because it grows by 30% each year. So remember, you're including the initial 100% in there, so that's 1.3. What we don't know is the time, so we're going to put that to the power of n. We do know that the answer is going to be bigger than 12 metres. For this kind of question, you need to apply trial and error. So we're going to play around with what that power of n could be. I'm going to start with 5. When I put into my calculator 2 times 1.3 to the power of 5, I get 7.42586, and that's not bigger than 12. So I need to try a higher power. So I'm going to go for 6. When I put 2 times 1.3 to the power of 6 into my calculator, I get 9.653618, which is still not bigger than 12 metres. It's got to exceed 12 metres. So I'm going to try the power of 7. And this time I get 12.5497034, which is just over 12 metres. So I can say here that the tree was planted for 7 years. Sometimes it's not obvious what the time is supposed to be in a question. A car is travelling at a speed of 30 kilometres an hour. It starts to accelerate. For every kilometre it travels, its speed increases by 15%. What will the car's speed be after it has travelled 5 kilometres? Give your answer to 3 significant figures. So I'm going to put this in my formula. What have I got? So the initial amount is how far the car is travelling to start with, and that's 30 kilometres an hour. The multiplier, that's the percentage by which it speeds up. That's 15%. Remember, because we're adding that onto the initial amount, it's going to be 1.15. Now, the power of time. There's nothing in here that tells us how long the car has been going for. It's what will the car's speed be after it has travelled 5 kilometres. With this kind of question, you just need to remember that it's talking about how many kilometres per hour. So the time is implied in that question. So for your power of time, you're thinking about what the car's speed was after it had travelled 5 kilometres. Whatever amount of time that is, the power of time is going to be 5. When you put that into your calculator, you get 60.34071563. It asks you to give your answer to 3 significant figures. That's 60.3. Just check the next digit in case we need to change that 3, and we don't. 60.3 kilometres an hour. This time you have to change the order that you do the calculation. The number of microorganisms on a Petri dish increases at a rate of 30% each day. After 6 days, the number of microorganisms is 7,500. How many microorganisms were in the dish originally? So if we look at the formula here, what information do we have? Well, we have the multiplier, so we're multiplying something by 1.3, because remember, the number of organisms is growing by 30%. We also have that it's for 6 days, so we know that that is to the power of 6. And we know that the final number of organisms will be 7,500. What we don't have is the initial amount. We're looking for how many we had at the beginning. So we're going to put n for the initial. And what we need to do with this one is to use the inverse, working backwards to get back to what the initial would have been. So 7,500, and we're going to use the inverse, which is dividing. And we're going to divide that by 1.3 to the power of 6. So you key that into your calculator exactly as you did before. And this will give you 1,553.821583. Generally, for this sort of question, they would ask you to give the whole number, because it's asking you exactly how many microorganisms were in there. So if we round this to the nearest whole number, that 3 will need to go up to 4, because the next number after the decimal point is an 8. So the original number of microorganisms in the Petri dish was 1,554.